Hi, my name is Edward Elliott and I'm a lecturer in the philosophy department at the University of Leeds. In this short series of video tutorials, I want to introduce to you some of the fundamental ideas and concepts of probability theory, especially as they apply to the study of philosophy. Now, in the last video, we talked about one of the possible interpretations of probability, where an interpretation of probability is roughly an answer to the question, what do probability functions represent? Or if someone were to say that the probability of some outcome A is, suppose, 20%, then what exactly does this mean? So we're going to continue on with that topic today, and in this video, we're going to be considering what's often called the epistemic interpretation of probability theory. The word epistemic derives from the ancient Greek word episteme, which means roughly knowledge or understanding. And the epistemic interpretation of probability is called that because it says that probability claims tell us about coherent degrees of belief. So what does that mean? Well, let's start by distinguishing between beliefs and degrees of belief. So everyone should have an idea about what beliefs are. There are various different things that you believe. I assume that you probably believe that 2 + 2 = 4, that the Earth is an oblate spheroid, and you will probably also believe that the universe began with a Big Bang. Now notice that when I describe beliefs in this way, they're the sorts of things that you either have or you don't have. You either believe that 2 + 2 = 4, or you don't believe it. But if I describe your beliefs in this way, it seems like I might be missing out on some important information. In particular, it seems like some of your beliefs you have more strongly than other beliefs. For example, it seems plausible that you will be more confident that 2 + 2 = 4 than you will be that the Earth is an oblate spheroid. The one is a mathematical truth, and a very, very simple mathematical truth. And so because of that, you will probably be around about 100% confident that it's true. Whereas on the other hand, perhaps the conspiracy theorists were right and the Earth is in fact flat after all. That's not very likely, but it's not impossible either. So perhaps you're only, let's suppose, 99% confident that the Earth is an oblate spheroid. And speaking for myself, I'm only about 90% confident that the universe began with a Big Bang. It's something that I believe is true, but on the other hand, I'm not absolutely confident that it is true. The evidence that we have in favor of it is quite indirect, and there are alternative ways of explaining that data. So notice that in this case, I'm describing my beliefs in a more nuanced way. I'm describing them as though they have different strengths, as if some of my beliefs might be stronger or weaker than other of my beliefs. So when philosophers talk about degrees of belief, this is the kind of thing that they're talking about. You can think about them as different levels of confidence that you might have towards all the different claims that you might consider. And since these come with different strengths, it seems like the sort of thing that we might be able to measure. So imagine that you were to draw up a scale with 0 at the bottom, 1 at the top, and all of the different values in between. At the bottom of the scale will be those things that I have no confidence in whatsoever. For example, the different logical impossibilities. It is absolutely impossible for it to be both raining and not raining at the same time, so that's something that I have 0 confidence in, and as a result it gets assigned a value of 0 on this scale. If I were to, let's say, flip a coin, then I would only be about 50% confident that the coin will land heads, and that will get assigned a 0.5 on this scale. Whereas these other claims that we've been discussing, the Earth is an oblate spheroid and that the universe began with a Big Bang, since I am very much more confident in these claims, they will get assigned a higher value. Now of course, these are just a very small few claims, but you might think that you could do exactly the same thing for everything that you consider. After all, if it's the sort of thing that you might consider, can it be true or false, then it's also the sort of thing for which you might be more or less confident about whether it's true. So that's the notion of degrees of belief, but as we said, the interpretation of probability that we're talking about here is of coherent degrees of belief. So now let's talk about what coherence means in this context. Once again, it will be helpful to contrast this with the case of belief. So imagine that a person were to believe, on the one hand, that Plato was a philosopher, but then also believe at the very same time that Plato was not a philosopher. Now there's a very clear sense in which these two beliefs are not coherent. They do not fit well together. And that's because they are logically incompatible. It's not possible for them to be both true at the same time. But now, when we talk about degrees of belief, we mean something slightly different when we talk about coherence. So imagine that this person were to say to you that they're 80% confident that Plato was a philosopher, and at the same time, they're 90% confident that Plato was not a philosopher. Now this isn't a logical contradiction like the case that we just considered, but there's still something very wrong with this set of degrees of belief. There's something that doesn't fit right. If this person were really 80% confident that Plato was a philosopher, then surely they should be very much less than 90% confident that Plato was not a philosopher. It just doesn't make sense to have a high confidence in two logically incompatible claims. Or consider another example. Suppose I were to tell you that I am 5% confident that I will win the lottery tomorrow. But at the very same time, I'm also 0% confident that I won't win the lottery tomorrow. Something has very clearly gone wrong here. I'm either going to win or not win, and if I'm only 5% confident that I'm going to win, then it seems that I should be 95% confident that I won't win. So something doesn't add up. There's something wrong with having these degrees of belief, or a little bit more precisely, there's something wrong with having both of these degrees of belief at the very same time. And we might describe what's wrong with them by saying that they are not logically incoherent, but rather probabilistically incoherent. That is to say, those degrees of belief fail to satisfy the three axioms of probability that we talked about in the second video. So recall from the second video just what those three axioms are. Axiom 1 says that the probability of any outcome must be no less than 0. Axiom 2 says that the probability of the necessary outcome must be 1. And Axiom 3 says that if any two outcomes are inconsistent, then the probability that at least one of them will obtain must be equal to the sum of their probabilities individually. So now we can rephrase these axioms in terms of degrees of belief, and if we do so, they will instead look like this. 1. Your degree of belief for any claim whatsoever must never be less than 0. Now this one you might think is not particularly interesting if we just make it a matter of definition that your degrees of belief are always measured on a scale from 0 to 1. If we do that, then it just falls out as a consequence of how we measure the degrees of belief that this axiom is always satisfied. However, Axiom 2 does seem to tell us something substantive about what our degrees of belief ought to be like. Put in terms of degrees of belief, it says, if a proposition is necessary, then your degree of belief about that proposition must always be exactly 1. Or in other words, for any proposition which is necessarily true, for example a logical tautology, then you must have 100% confidence with respect to that proposition. And this one is actually quite a lot harder to satisfy, because it basically says that you have to know all of the logical truths, or rather you have to be 100% confident with respect to every single logical truth. And if you don't do this, then there's something incoherent about your degrees of belief, and that's actually a very strong standard to try to satisfy, especially if you haven't studied much logic. Even stronger still is the third axiom, which put in terms of degrees of belief now says that if any two claims are inconsistent, then the probability that at least one of them will be true must be equal to the sum of their individual probabilities. And this one is even harder to satisfy than the second axiom. For example, it's not always obvious when two claims are actually inconsistent with one another. It might in fact take a lot of work to try to prove this. So it seems that if we take probabilistic coherence as the standard that our degrees of belief have to satisfy in order to be coherent, then none of us are actually going to be coherent. But this maybe isn't so bad. Instead of taking this as a plausible standard of coherence for ordinary people, you might instead take it as an ideal standard, the kind of thing towards which we should all aim even if we never actually get there. And this is what the epistemic interpretation of probability actually says. Essentially, those three axioms of probability tell us about what an ideal set of degrees of belief ought to be like. And if we want it to be perfectly ideally rational as well, then we should try to make our degrees of belief conform to those axioms as much as possible. This is in kind of like the same sort of way that you might think of the laws of logic, where it's plausible that when it comes to your ordinary beliefs, you ought not to believe things which are logically inconsistent. So an ideal standard in this case is logical consistency, even if, as a matter of fact, that might be something which is too difficult for us to actually obtain. So that's the epistemic interpretation of probability. In the next video, we're going to talk a little bit more about it, and in particular, we're going to discuss the reasons why anyone would think that probability tells us about rational degrees of belief.